Picture the scene. It is 2025. You are sitting in a glass-walled conference room, or, maybe it's a high-stakes Zoom call with a blurry background because you forgot to clean your office.
Oh yeah, we have all been there.
Right. And across from you is the engineering director for a major tech firm. You have nailed the pleasantries, you talked about your background, you were feeling pretty good.
And that is usually when the curveball comes, the exact moment where the vibe in the room shifts.
Exactly. They lean forward, look you dead in the eye, and ask, so tell me about agents.
And that is the moment where generic answers just go to die. 2 years ago, sure, you could say it's a chatbot that remembers things, but today,
Yeah.
that answer gets you walked out of the room.
Because the industry has completely shifted. We are not just looking at text generation anymore. We are looking at action. And that is our mission for this deep dive today.
Yeah, we are moving into the era of agentic AI.
We really are. And we have gone through a massive stack of sources for you. Dense papers on reinforcement learning from Arcus, the latest industry benchmarking from artificial analysis, basic definitions from Wikipedia, all to build you the ultimate cheat sheet for your next interview.
And we have boiled all of this down to exactly 12 specific questions. These are not just trivia questions. They are the structural pillars of understanding modern AI.
We are going to move from the basic definitions to the messy architecture, and finally into the complex theory that usually trips people up, because the goal isn't just to memorize the answer, it is to understand the why.
Right, because if you understand the why, you can handle the follow-up questions. And handling the follow-up questions is what actually gets you the job.
So let's just get right into it. Part 1, the foundations. Question number 1. It sounds deceptively simple, but the nuance really matters here. What is an AI agent?
So if you look at the definitions in the artificial analysis report, or even just Wikipedia, they all converge on 3 specific keywords. And if you miss these, you completely miss the definition. An agent is a software entity that perceives its environment, makes decisions, and takes actions autonomously.
Perceive, decide, act. It almost sounds like a mantra.
It really is. But here's the key distinction to make in an interview. A standard program, like a calculator or a basic Python script, is passive. It waits for input.
It basically sleeps until you poke it.
Exactly. But an agent has agency. It perceives its environment continuously, makes a decision based on that perception, and takes an action to change that environment to hit a specific goal.
So a calculator waits for me to type 2 plus 2, but an agent sees that I am trying to do my taxes, realizes I am missing a receipt, and goes and finds it without me even asking.
That is the leap. It is that autonomy loop. It is not just processing data. It is initiating action.
Which brings us directly to question number 2. Because this is probably the most common confusion point for non-technical people. I mean, my grandmother thinks ChatGPT is an agent, so how does an autonomous agent differ from a standard chatbot?
This is the consultant versus employee distinction. If you use this analogy in an interview, you look like a total pro.
I loved this analogy from our notes. Walk us through it.
Okay, so a chatbot is like a consultant. You hire a consultant to talk. You ask them questions, they give you advice, maybe they write a nice report. But at the end of the day, you have to go execute the advice.
Right. The interaction is purely conversational.
Yes, the output is just text. But an autonomous agent is like a trusted employee. You do not want to chat with them all day. You want to say, book me a flight to London, under $600, aisle seat, and then you want to completely stop thinking about it.
You want them to do the work.
Exactly. The agent acts independently to complete the task end to end. It goes to the website, navigates the UI, enters the credit card, and sends you the confirmation. No constant human input needed.
So the output isn't text. The output is a completed task.
And looking at the 2025 industry trends, that is the defining shift. We are moving from chat to work. If you are interviewing for an AI role right now, you need to emphasize that you are building workers, not just talkers.
Okay, so we have perceive, decide, act. Let's get a bit more technical for question number 3. If you are talking to an engineering manager, they're going to want to know what that interaction looks like mathematically. What are the 3 core signals in an agent environment interaction?
This comes straight from the reinforcement learning literature on Arcarian. The interaction is reduced to 3 primary signals: actions, states, and rewards.
Let's break those down, because state can be a bit of an abstract concept for some people.
Think of it like a video game.
Right.
Let's say the agent is playing Super Mario. The state is the literal snapshot of the screen at this exact millisecond. Where is Mario? Where's the Goomba? Where's the cliff? It is the raw data of the world right now.
Okay, got it. And the action?
Jump, run right, duck. It is whatever decision is executed by the agent in that specific state.
And then the reward.
This is the feedback. In Mario, the positive reward is the score going up or grabbing a coin. A negative reward or a penalty is falling into a pit.
It seems simple enough, but this loop is really the heartbeat of the whole system, right? The agent looks at the state, chooses an action, and waits for the reward to tell it if it's screwed up.
And that feedback loop is entirely how it learns to function. Unlike a human who you can just verbally explain the rules to, an agent often has to feel out the boundaries of the system through these signals alone.
It learns the physics of the world by banging into the walls.
Basically, yes.
Let's move to part 2, the architecture. We know what an agent is, but what is actually inside it? This is where we see the biggest changes recently. Question number 4, what role does a large language model, or LLM, play in modern agents?
This is a huge pivot point in the industry. Historically, agents were these rigid, hand-coded logic loops. If X happens, then do Y. Today, the LLM is the engine.
I have heard people describe it as the router or the cognitive core.
Both work perfectly. The LLM isn't just generating text here. It dynamically directs processes, plans workflows, and manages tool usage based on your high-level instructions.
So it takes a vague command like plan a vacation, and it breaks that down into steps.
Right. Step 1, search flights. Step 2, check hotel availability. It is generating the plan. It decides what to do next.
You mentioned tools just now. That is question number 5. What are common examples of tools used by AI agents?
If the LLM is the brain, the tools are the hands. An LLM by itself is trapped in a box. It only knows what it was trained on. Tools let it actually touch the real world. Common examples are reading and writing files, making web requests.
And the really big one, executing code.
Huge. The ability to write and run code on the fly lets the agent solve math problems or analyze data that the LLM itself might just hallucinate on. But, and this is crucial, the sources emphasize executing code in sandbox environments.
Why is that specific word, sandboxed, so vital to bring up in an interview?
It shows you understand enterprise safety. You cannot have an AI agent running raw code directly on your user's computer or your production server. What if it hallucinates and decides the most efficient way to organize files is to delete the operating system?
That would be highly efficient, but you would definitely be fired.
Immediately. A sandbox is an isolated, safe environment where the agent can run code, break things, and fail without crashing anything important. Mentioning that shows you care about infrastructure.
The notes also mentioned MCP, the Model Context Protocol.
Yes, think of MCP as the universal USB port for AI. It is a standard way for the brain to plug into the tools, making these connections much more reliable.
I like that, the USB port for AI. Okay, let's get cerebral. Part 3, the theory. This is where you prove you actually know the science. Question number 6, define a rational agent in AI theory.
You have to be careful here. Rational doesn't mean sane or human-like. In AI theory, a rational agent is one that takes actions to maximize its chances of achieving defined goals based on its utility.
Utility. That is the magic word.
It is all about math. Utility is just a score. Did the action increase the score or get the agent closer to the goal? If yes, that is rational behavior.
This reminds me of the famous paperclip maximizer thought experiment.
Exactly. If you define an AI's only utility as making paperclips, it will eventually turn the entire universe into paperclips. That is technically a perfectly rational agent. It is maximizing its utility function.
So in an interview, acknowledging that defining the utility function is the actually hard part shows real depth.
Right, because if you define the rewards poorly, you get a rational agent doing terrible things very efficiently.
Question number 7. This term comes up constantly in the ArcLove papers we reviewed. What is a policy?
Formally, a policy is the internal strategy or mapping that guides an agent to select a specific action based on its current perceived state.
Input is what I see. Output is what I do.
Exactly. Think of it like a playbook in sports. The quarterback looks at the defense, that is the state. He checks his playbook, that is the policy. It dictates, if they are in this formation, throw to this receiver.
So the policy is the rule book the agent follows.
Yes. And training an agent is basically just refining that rule book over and over.
Which leads us perfectly to question number 8. How does reinforcement learning, or RL, improve agent performance?
Through trial and error. RL enables an agent to learn by receiving rewards for positive outcomes and penalties for negative ones to maximize success. The source material talks a lot about evaluative feedback here.
How is evaluative feedback different from normal supervised learning?
In supervised learning, you are told the right answer. Here is a picture of a cat. It's a cat. In RL, you have to figure it out. It is like learning to ride a bike.
The bike analogy is great.
Right. You don't learn to ride a bike by reading a manual. You learn by getting on, falling over, feeling the penalty of hitting the ground, and adjusting your policy so you do not fall next time.
There is a tricky concept related to this called the credit assignment problem. Can we touch on that briefly?
Absolutely. Say your agent plays a full game of chess and wins. It gets a massive positive reward at the very end of the game. But which of its 50 moves actually caused the win?
Was it the brilliant opening or just a lucky move at the end?
Exactly. The agent has to figure out how to assign credit for that final reward back to the specific actions it took along the way. Explaining that in an interview shows you deeply understand the mathematical challenges of RL.
We are doing great. We have the basics, the architecture, and the theory. Let's ramp up the complexity for part 4, strategy. Question number 9, what is a multi-agent system, or MAS?
A multi-agent system is exactly what it sounds like. It is a system composed of multiple interacting intelligent agents working together to solve problems that are too complex for a single agent.
Why not just build one really smart agent to do everything?
Because of specialization. Think of a soloist versus an orchestra. You have different agents with different tools, a web search agent, a coding agent, a writing agent. But the really hard part is they have to interact.
The sources refer to this as theory of mind, right?
Yes. Agent A needs to understand that Agent B has its own state and its own goals. They have to coordinate without stepping on each other's toes. That is incredibly difficult to engineer.
Question number 10. This is a classic dilemma, and it applies to human psychology too. What is the exploration versus exploitation dilemma for agents?
This is the challenge of balancing trying new actions to gather information, which is exploration, versus using known best actions to maximize rewards, which is exploitation.
Give me an example of how that plays out.
We use the restaurant problem in RL a lot. Let's say you want to maximize your utility, which is a good dinner. You know a burger joint that is pretty good. Going there is exploitation. You know you will get a reliable reward.
But if I only go there, I might miss out on a brand new sushi place that is amazing.
Right. Trying the sushi place is exploration. It might be terrible and you get a negative reward, but it might be incredible. If an agent never explores, it gets stuck in what we call a local optimum. It is doing okay, but it never finds the truly optimal solution.
So it has to balance the risk of trying the unknown against the safety of what works.
Exactly. And coding that balance mathematically is a huge part of agent design.
Question number 11. What are model-based agents?
Model-based agents use a predicted map, or a model of their environment, to simulate future states and rewards.
So instead of just reacting to what is happening right now, they're thinking ahead.
Yes, it allows for strategic planning. The agent essentially asks itself, if I do action X, what will happen in the environment? It simulates the future before taking the risk of acting in reality. Efficiency is the key here.
Okay, we are down to the final section, part 5, the now and next. This is for when the interviewer leans back and asks what you are seeing in the market today. Question number 12, name a recent advancement in agentic services.
The landscape is moving so fast, but the big shift right now is computer use. Recent examples include OpenAI's Operator, which executes goals by navigating websites, and various agent builder platforms that let you design workflows with very limited coding.
The artificial analysis charts we looked at showed this massive explosion of these capabilities in late 2024 and 2025.
Models like Grok 4 Fast and Claude 3.5 Sonnet are specifically being trained for tool use. We're seeing a huge shift toward post-training optimization.
Meaning they aren't just trained on language anymore.
Right. After they learn to speak, they are explicitly trained to be better employees. They learn how to move a mouse, click buttons, and recover from errors on a web page without giving up. We're moving toward agents that use a computer exactly like a human does.
Wow, we made it through all 12. That is a lot of high-stakes material.
We've covered a ton of ground today.
Let's do a really quick summary. We went from defining the agent, perceive, decide, act, to its brain, the LLM, and its hands, the tools operating in a sandbox.
We covered the RL learning style, balancing exploration and exploitation, and maximizing utility.
And finally, the future, with multi-agent systems and actual computer use.
The big takeaway here is that knowing these definitions proves you understand the architecture of modern AI, not just the marketing hype.
Absolutely. Before we sign off, I want to leave you, the listener, with a thought based on that exploration versus exploitation dilemma we talked about, because it really applies to your own life.
It really does. It is a mathematical truth, but a very human one, too.
In your own career, are you just exploiting what you already know? Are you relying on the same skills you learned 5 years ago because they are safe and reliable? Or are you exploring enough new technologies, like AI agents, to find your maximum reward?
If you do not explore, you get stuck in that local optimum.
You really do. You have to take the risk to find the breakthrough. Well, thanks for taking the deep dive with us today.
See you on the next one.
If you enjoyed this video, please subscribe and support the channel. More exciting AI questions and insights are coming soon.